Now we talk about Tubepro Quick Debugging. There are three main aspects to the setting. They are return origin, capacitance calibration, and calibrate B-axis center. The default y-axis coordinate is 9,999. If the soft limit is less than it, it will report y-axis positive soft limit alarm. At this time we need to click Quick Set Job Param. Turn off Enable Soft Limit Protection. Click Save. Now the alarm is cleared. Then we confirm the travel distance and direction of all axes. Open Quick Set Job Param. Set step distance as 1 mm. Click Save. Check Step option. Jog the x-axis left and right. Facing the chuck, the cutting head moves to left in x negative direction. The cutting head moves to the right in the x positive direction. Jog the master chuck, the chuck moves to cutting head in y positive direction. The chuck moves away from cutting head in y negative direction. Jog the rotation axis. It moves clockwise in B negative direction. It moves counterclockwise in B positive direction. The cutting head moves down in Z positive direction. The cutting head moves up in Z negative direction. After confirming the travel distance and direction of each axis, click Tool, Monitors, Motion Control Monitor. The switching status of each axis can be monitored. Trigger the limit switch at this time. The status of limit switch in the monitor will change from off to on. By this, we can judge the limit switch is connected to the system or not. If not connected, we need to check if the wiring is correct or not. After confirming the travel distance and direction of each axis, and the status of the limit switch, then the return origin of each axis or all return origin can be carried out. The tube capacitance calibration is similar to the plate cutting system. By jogging the X, Y, and B axis, move the rectangular tube under cutting head to ensure the upper surface of rectangular tube is level. Then jog the Z axis. Move the cutting head close to the tube surface. Then click Capacitance Calibration. Confirm. Just click Start Calibration. Calibrate B-axis center. By jogging the X, Y, and B axis, move a standard rectangular tube without chamfer under the nozzle of cutting head. The tube should be a rectangular tube without chamfers, because the chamfers will affect the accuracy of B-axis calibration. After the rectangular tube moves under the nozzle, adjust B-axis to keep the upper surface of this tube level. Then enter the width and height of the rectangular tube. Click Start. The cutting head will perform the action of B-axis calibration. After calibration, the calibration results will appear at the mechanical center coordinates. Just click Save. At this point, the debugging steps are basically completed. In the interface of Manual Debug, we can control the clamping and loosening of the chuck. We can also control the rise and fall of the tube holders. When the chuck and bracket are raised into place, or when clamped in place, corresponding rise and fall, clamp and release buttons will turn dark accordingly. At this point, if we debug the holder, we need to jog the y-axis. Move close to the tube holder, by this to determine the y-axis descent and limit coordinates of the respective tube holders. According to the design indicators of the machine, we can get the maximum speed of the y-axis. The multiplication of the maximum speed of y-axis and the time corresponding to the tube holder should be less than the difference of the y-axis limit coordinate and the y-axis descent coordinate. This is to prevent the chuck from hitting the holder. By jogging rise and fall of the tube holder, we can calculate the approximate rise and fall time of the tube holders. By this, we can set the default time of holder to be in place. Similarly, by jogging the chuck clamping and loosening, the default time of chuck clamping and loosening in place can be calculated. These values can be filled as the default in-place time into the Machine Config tool. Once the in-place time is set up, The configuration of the master chuck and tube holder is also set. After the parameters are configured, how do we save them to ensure the next machine of same model to make a call? There is an About in the File drop-down menu. Here we can see the version of CNC system and release date, the control card type and card ID, follower type and laser type. In the License section, we can find the QR code of control card. By scanning the QR code, we can generate registration code to extend the service time of the control card. As for this demo version, it's not available. The industrial PC specs can also be found here. Let's move to Backup in the File drop-down menu. Click Backup. Choose a file path where you want to save. Enter the name of the config backup. Click Save. Now the config backup is completed. The config backup will be saved on the corresponding path. When we want to restore the config backup, we can turn off the software. Double-click the config backup. Check the file types to be recovered in the list. Here the machine config refers to the parameters in machine config tool. Here user config refers to the jog speed and parameters in global setting. PLC config means the PLC parameters during PLC process. Script config refers to the JavaScript config saved in previous bus condition. It's notable that the configurations in Win7 and Win10 are different. Generally, check the corresponding file types in the list. Click Recover. The latest saved parameters will be restored into the current system. When we lost our backup parameters accidentally, or when the software is accidentally deleted, we can restore them with the backup config. We can also recover the backup config for the next same machine.